Good evening, everyone. In the last class, we have discussed about sets and roster form and set builder form. That is representation of sets in roster form and set builder form. Today, we are going to discuss about types of sets. There are different types of sets. We shall learn what are they. Before that, we need to know a term called cardinal number. Cardinal number of a set. We need to know this cardinal number of the set. First of all, set is collection of well-defined objects, and we represent that in roster form and set builder form. In roster form, we will represent every element of the set and say 1, 2, 3, 4, 5. And in set builder form, we will write the definition, that is x such that x is a natural number less than 6. That means we need to consider a rational number less than 6, that is 1, 2, 3, 4, 5. So these are representation of set. Here, how many elements are there in this set? 1, 2, 3, 4, 5. There are 5 number of elements. Let us say this is set A, and this number is denoted as n of, and this is cardinality or cardinal number of the set. Cardinality or cardinal number of the set. Say n of A. Number of elements in a set is nothing but the cardinal number of that set or cardinality of that set. If you have two, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. Same. This is set of even numbers less than 13. Set of even numbers less than 13. So 2, 4, 6, 8, 10. Number of elements is 6. 1, 2, 3, 4, 5, 6. So n of k is 6. That is cardinality or cardinal number of the set. Cardinal number of the set is 6. This is how cardinality of the set is defined. Now, by using this, we are going to see different types of sets. First one is null set. This is also called as empty set or void set. Null set, empty set or void set. The set name itself suggests that there is no element in the set. That means the set is empty. There is no element in the set. That means there is only factors. The null set or empty set or void set is represented by only flower brushes or 5. Null set is represented by only flower brushes or 5. That means there is no element in the set. If you have 0 is the element of the set. So we can't say this is empty set. Say, if I ask you to write a set of even prime numbers other than 2. A set of even prime numbers other than 2. That means, do we have any other prime number, any other even prime number other than 2? We have 2, 3, 5, 7, 11, 13, 17, 19, and so on. But this is the only even prime number. Other than 2, every other number is divided by 2, and they have more than 2 factors. Every other even number have more than 2 factors. So they are not prime numbers, they are composite numbers. Here 2 is prime number because it has only 2 factors, 1 and pixel. That is 1 and 2. So 2 is the only even prime number we can write. If we are asked to write a set of even prime numbers other than 2, then that is empty set. There is no element in the set. So this is the representation of empty set. So that is empty set or null set or void set. This is represented by flower basis of 5. Greek letter 5. Let us go for angle. Second one is singleton set. Singleton set. The name has single. Single means one. If the set has only one element, then that type of set is known as singleton set. If a set has only one element in it, if a set has only one, we can write set of even prime numbers, that is 2. In this set we have only one element, that is 2. Or else set of whole numbers which have only one factor, that is 1. One has only one factor, that is only 1. So set of whole numbers which have only one factor, that is 1. So we have only one element in it. So this is singleton set. So if we have only one element in the set, then that type of set is known as singleton set. Let us go for third set. Finite set. Finite means which has a stop, which stops at some point, which stops at a point. That is finite. That means if you are writing a set, if you have countable number of elements, then that type of set is known as finite set. Let us say 1, 2, 3, 4, so on. This is natural numbers up to 100. Then we have 100 elements in it. That means we can count the number of elements in this set. If we can't count the number of elements in the set, that is say 1, 2, 3, 4, 5, so on. This is set of natural numbers. If we are given a set of natural numbers, we don't know how many elements will be there in that set. So that is infinite set. Infinite set. If the cardinality of the set can be defined or cardinal number of the set can be known, then that is finite set. If the number of elements in the set, that is cardinal number of the set, is unknown, then that is infinite set. One is finite set and the one is infinite set. Till now we have learned 4 types of sets. One is void set, that is empty set or null set. Second one is singleton set. Third one is finite set. Fourth one is infinite set. Now we shall go for universal set. This is represented by mu or capital U. Universal set. If you are given universal, the objects under the universe, every object under the universe comes under this set. Suppose if you are considering a set of natural numbers, till n. If you have 1, 2, 3, 4, 5 as a set. For this set, this is universal set. That means every natural number is counted in this set. But this has only 1, 2, 3, 4, 5. This is set. So whatever that can be taken into consideration in a particular situation. That means all the elements under the universe are considered as universal set. All the elements which can be considered are known as universal set. Next we shall go for equal and equivalent sets. Equal sets, equivalent sets. Equivalent sets. If A has 1, 2, 3 and say B has P, Q, R. Then number of A is, that is cardinality of A is 3 and cardinality of B is 3. If these both are equal, if the cardinal number of two sets, any two sets is equal, then they are said to be equivalent sets. If the cardinality of any two sets are equal, then they are said to be equivalent sets. Equivalent sets. If all the elements of A are present in B, if all the elements are A are present in B, nothing more than that and nothing less than that. Suppose say A is 1, 2, 3 and B is 3, 1, 2, 3. One is present in A and one is present in B. 2 is present in A and 2 is present in B. 3 is present in A and 3 is present in B. Then this type of sets are known as equal sets. These type of sets are known as equal sets. If every element of A and B are same, if every element of A is present in B, then they are equal sets. That means for equal sets, there should be n of A is equals to n of B, and all the elements should be present in both the sets. In equivalent set, the elements are not taken into consideration. The only cardinality of the sets are taken into consideration. So that will be equivalent sets if n of A is equals to n of B. If n of A is equals to n of B and the elements are equal, same, then they are said to be equal sets. Now let us go for joint and disjoint sets. Joint and disjoint sets. Joint means which are combined together. That is joint. Say A is equals to 1, 2, 3. C is joint sets of A and B. That means every element of A and B are present in C. Every element of A and B are present in C. So that is joint set of A and B. Suppose if there are no common elements. Sorry, this is union. This is also known as union. Disjoint sets means if there are no common elements in the set. Suppose if you are taking A as 1, 2, 3, same like that, 4, 5, 6. There are no common elements in A and B. Then they are known as disjoint sets. If there are no common elements, if they are combined together, they are joint sets. If there are no common elements, then they are disjoint sets. And in joint sets, we will have at least one element in common. Previous that was union. So if we have at least one element in common in both sets, then they are said to be joint sets. And if there are no common elements, then they are said to be disjoint sets. Joint sets if there is at least one common element. Disjoint sets if there are no common elements. That is disjoint sets. Next we shall go for subset and power set. Subset superset. So subset. If you are considering a set 1, 2, 3, and if you are considering B as 1, 2, 3, 4, 5, we have 1, 2, 3 in A and 1, 2, 3 in B. Apart from 1, 2, 3, we have other elements in B. That means A is subset to B. If every element of a set is present in the other set, and if there are more than that, then that is A is subset to B. If there is only B is said to be only 1, 2, 3, then A is subset or equal set to. So if there are elements of A in B and B has more elements than A, then you can say A is subset to B and B is superset to A. So this is how we can define subset and superset. Subset is if you have same elements as A in B and if you have more elements in B, then that is A is subset to B is said to be superset to A. Now, if you are taking only one set, that is, we can write subsets to this set. Subsets to this set are null set, the same set, and we have to consider one element at a time. And we have to consider two elements at a time. Already you have joined 2 with 1, so we have to join 2 with 3. Already we have joined 3 with 2 and 1. 1, 2, 3, 4, 5, 6, 7, 8 subsets. These are all subsets of A. 1 is subset of A. 2 is subset of A. 3 is subset of A. 1 comma 2 is subset of A. 2 comma 3 is subset of A. 1 comma 3 is subset of A. Null set is subset of A and the same set is subset to A is subset to 1, 2, 3, 4, 5, 6, 7, 8. That means null set and the same set are subset to every set. Null set and itself are the same, subset to the set. Null set, the same set are subset to the set. And we have to consider one element at a time and two elements at a time. If you have more than that, you have to go for three elements at a time, 4 elements at a time, like that. Suppose if you have A is equals to P, Q, R, S. We have 4 elements here. Now we have to go for null set is subset to A and the set that is P, Q, R, S is subset to A. Now we have to consider one. Next we have to consider 2 elements at a time. PQ, PR, PS. Next, as we have joined P and Q at a time, next we have to go for Q and R and Q and S. Next, already R is joined with P and R is joined with Q. That means if you are writing R, Q, this is nothing but this set equals this set itself. So we need not consider this set again. Q, PR, PS, QR, QS, RS. S is SNP, SNQ, SNR. R is combined with every element. RP, RQ, R is combined with every element. RP, RQ, RS, RS. QP is combined with every element. PQ, PR, PS. Q is combined with every element. QP, QR, QS. Like that, you have to combine with everything. Next, we have to consider three elements at a time. That is PQR, PQS. Next, QS. Next, PQR, PRS. Sorry, PQS. Next, PR. Already we have taken Q, so PRS. Next, with S we have combined with PS, PS, PR, PQ. So PQ, PQ, PR. Already we have taken PS, PS. So we need not consider that again. And we are going for Q again now. Q, Q, PR, Q, PR. Already taken. Q, PS. Already taken. Q, PS is already taken. QRS is not taken. QRS is not considered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have got 16 subsets. 16 subsets. How we can determine number of subsets to a set? How can we determine number of subsets to a set? That is, number of subsets to any set can be 2 power n, where n is cardinal number of the set. Here the cardinal number of the set is 4. That means you can get number of subsets as 2 power 4, that is 16. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 subsets. If in the previous case there were only 3 elements in the set, that is 2 power 3. Number of subsets is 2 power 3, that is 8. That means in order to know the number of subsets to any set, we have to take 2 power n, that is n is cardinal number of the set. Then we can determine the number of the subsets. Number of subsets we can write for a set. So with this we have learned types of sets, that is empty set, singleton set, universal set, finite set, infinite set, subset, superset, joint set and disjoint set. These are the types of sets you need to learn so that you can continue with the second exercise of your textbook. With this I am concluding the class. Tomorrow we shall go for representation of sets in diagrams, that is Venn diagrams. If you have any doubts, you can ask me on WhatsApp so that I can clarify your doubts. Bye everyone.